More factoring today. We're taking a look at factoring by grouping, which is when you have a quadnomial or four terms, and you factor half of the quadnomial at a time, and then you factor one more time, pull out those binomials that they have in common here. The AC method is another way of factoring by grouping. You multiply the leading coefficient by the constant, set up a t-chart again, what multiplies to -6 and adds to 5. So very similar to the t-chart method, but unlike the t-chart method, you can't just throw those answers into a binomial. You have to factor by grouping. Finally, there is a way to factor perfect square trinomials. You can also factor perfect square trinomials using the t-chart or the AC method if you prefer. However, in this case, multiplying to 64, there's a lot of options versus recognizing the pattern that the first and last terms are perfect squares. The middle term is 2 times the first term times the second term. I will run through this formula for perfect square trinomials with you. If it confuses you, feel free to stick to the methods that you know. Day 2 of factoring, we still have the same essential question, so we're going to start with grouping. Notice that our first two terms have a common factor, as well as the second two terms, but all four terms do not have a common factor. Our first two terms have a common factor of 2x squared. Dividing that out of the first term, we have 4x cubed minus 3. Our second set of terms have a common factor of 3. Make sure you have a plus or minus sign here. I get a lot of students getting sloppy on their notation when they're doing factoring by grouping. What's left is 4x cubed minus 3. So notice how those two binomials, what was left over, is the same in each set. That is now a common factor. So I'm going to factor out the GCF again. What's left from the first term is 2x squared. What's left from the second term is a positive 3. Looking at example B, I notice that we have a GCF of 2 for all four terms, so I'm going to start by factoring that out. Then I can factor by grouping my first two terms and my second two terms. Don't lose that GCF. Here's where it gets a little tricky because this y squared that I'm factoring out is not a GCF for all four terms. I cannot put that with my 2, so I have to use that separator or a bracket. The reason I use a bracket is because now I'm going to use a parenthesis for writing what's left from those two terms. Again, do not lose the plus or minus sign when you factor the GCF from the second set of terms. Dividing out a -2, I get a y minus 4. If you factored out a positive 2, you would have ended up with a -y plus 4. Make sure that those two sets of parentheses that you end up with are the same. Otherwise, you cannot continue to factor by grouping. Now I can drop those brackets because this y minus 4 is a GCF for both terms inside the brackets. And then I'm left with the y squared from the first term and a -2 from the second term. Looking at AC method, this one we will start by setting up a t-chart, multiply that leading coefficient. Remember, with quadratic expressions, we have a, in this case y squared, plus by plus c. So this is why it's called the AC method. We're multiplying the leading coefficient by the constant and then seeing what adds up to the b term, that middle term again. 2 times 3 multiplies to 6. Since we're adding to a -5, I will make both of those values negative. Here is where we cannot throw it into binomials like we did last time. What those two values do is give us the way to split up that -5y so that we can factor by grouping. Keeping our 3y squared, our -5y becomes -2y minus 3y, and then we keep our plus 2. Now we can factor by grouping. My first two terms have a GCF of y, leaving me with 3y minus 2. My second two terms have a GCF of -1, leaving me with 3y minus 2. Now I have that 3y minus 2 in common for both terms, leaving me with y minus 1. For this one, I notice that my leading coefficient is negative. Once you factor, it just looks kind of messy to have that negative be the first thing inside the parentheses. So I'm simply going to factor out a negative from each of these. It's not wrong if you don't. I just think that it looks neater, so I like to do that. Now we can go on with our AC method. We're multiplying to a -90, that leading coefficient of 9, times the last term of -10, and adding to a -27. Now the obvious values that multiply to 90 are 9 times 10, but if I make one of those negative, they do not give me a -27. Another set of values that multiply to 90 are 3 times 30. If I make the 30 negative, 3 plus -30 does give me that -27. So remember, this is how I split up that value in the middle. So I'm going to keep my negative sign and use brackets. My 9x squared stays the same. Now my -27xy becomes a positive 3xy minus 30xy, and then I keep my -10y squared. Factoring by grouping, my first two terms have a common factor of 3x, leaving me with 3x plus y. My second two terms have a common factor of -10y, leaving me with 3x plus y. Finally, factoring out that common factor of 3x plus y, I am left with 3x minus 10y. This last page is a mix of different types of factoring. This first one is a perfect square trinomial. I recognize that because x squared and 25 are both perfect squares. So let me show you how that pattern works. You take the square root of the first term, the square root of the last term, and it's helpful to go in this order because the middle term needs to be 2 times the square root of that first term times the square root of that last term. -10 is -2 times 5, so when we factor this, we get x minus 5 squared. Now, a lot of students, when they see this method of factoring, ask, where did that middle term go, that -2x5? Well, think of it this way. If we were going to factor this with T-chart, we would be thinking about what numbers multiply to 25 and add to -10. Well, those numbers are -5 and -5. We have that here. We just simplified it into a binomial squared because they ended up being the exact same thing in both sets of parentheses. Let's take a look at that again. Our next one looks like it could be a perfect square trinomial. 16x squared is a perfect square. 1 is a perfect square. And that middle term is 2 times the 4x times the 1. So to factor this as a binomial squared, we take the first term and the last term. The sign that we keep is the sign on the middle term. Part C, this is actually a T-chart method because this first term is the square of the second term. So we're looking for what numbers multiply to 45 and add to 14. We get 5 times 9, and 5 plus 9 works as well. When we factor this, we use the value from that second term. So we're going to factor this into x squared plus 5 and x squared plus 9. Part D, we have a GCF of 6, leaving us with x squared minus 9. X squared minus 9 is a difference of squares, x minus 3 and x plus 3. Our very last example, we have a GCF of x, 2x squared minus 7x minus 15. Now we have an AC method inside the parentheses. What multiplies to negative 30 and adds to negative 7. 10 times 3 multiplies to 30. If we make that 10 negative, we get the right sign for our addition. Now we have to factor by grouping, splitting up that 7x as a negative 10x plus 3x. Factoring by grouping, I have a GCF on my first two terms of 2x, leaving me with x minus 5. The GCF on my second two terms is a positive 3, leaving me with x minus 5. And finally, pulling out that x minus 5, that's the GCF, leaving me with 2x plus 3. As a reminder, if the factoring perfect square trinomials pattern didn't make sense to you, you can always factor perfect square trinomials with either the t-chart if the leading coefficient is 1, or the AC method if it's not. So don't worry, I will not be testing on whether or not you know that method, just whether or not you can get it factored.